This was our starter 2 classes ago, and we spent 2 days on this lesson because it has a lot of content in it. So you started off just drawing 2 rays on your paper. Then you drew the union of 2 rays. And notice when you have the union of 2 rays that have a common endpoint, this endpoint is the same right here, okay, that we have what's called an angle. And when you have an angle, you can measure its size. And so in this lesson I taught you how to measure this, which scale to use, and how to measure this as 85 degrees. So that's what we're doing today, how to measure, draw angles, and some things with polygons. So when you first begin to draw an angle, you begin with just simply a ray. So I just draw a ray with my ruler. Next thing you do is align the center of your protractor, not the bottom edge, but the center of your protractor with 0 on the protractor and your ray. And you can see right here that I've got the number 0 and the number 180. And you always begin counting at 0. So if my ray is to the right, I'm going to use a 0. My ray is to the left, the 0 is on the outside. But my ray right now is pointing to the right and the 0 is on the inside scale. So I'm going to use that inside scale. So now I want you to draw a 114-degree angle. So I need to line up, make sure my center is on 0, make sure my ray is aligned with 0, use the inside scale. Here's 110 and go over to 114 and put a dot. That dot aligns with 114 degrees. And then move your protractor out of the way, take your ruler and draw another ray from the same common endpoint through that dot, because this opening, this arc, which is a part of a circle, is 114 degrees. Remember, the entire circle, a full circle, is 360 degrees, and we're going to get to why in just a minute. So then I had you try one, draw an angle of 150 degrees. You began with your ray, and then you were on the inside scale. You found 150 degrees, put a dot, and then move the protractor out of the way and draw a ray from your common vertex through that dot, put your arc and label it 150 degrees. To measure an angle, you begin by aligning your protractor with one of the rays, and I'm going to use this one here just because it's convenient. I'm on the inside scale because I count at 0, and I go around and I have to see where this lines up. I put 85 degrees, but it really does look like it might be more like 86 degrees. The width of this arrow is 1 degree all by itself, so you just have to really be careful. I got to make sure that's right on 0. So yeah, if I really make sure that's aligned on 0, it looks like it lines up with 85 degrees. So a union is simply an angle rather, is simply the union of 2 rays with the same endpoint. And that same common endpoint is called the vertex of the angle. So the vertex is right here. That's a ray, and that's a ray. This is an arc, and it's a part of a circle, just like a segment is part of a line. If I have more than one vertex, they're called vertices. So off comes the EX, and on goes ICES. So 1 is vertex, 2 or more are called vertices. This symbol says the word angle. So remember, in geometry we try to be really efficient and we try to make things as short as possible. So this angle is facing right. This is the same angle opening to the left. I can call these angles angle B because there's only one vertex and there's no confusion what angle I'm talking about. It's just angle B. Or I can call it angle ABC or angle CBA. Notice that the vertex is in the middle, or it's the name of the angle by itself. So you can name an angle 3 ways. However, if there's more than one vertex, you must use all 3 points. So more than one vertex would be a situation like this. I have an angle here, and then I have another angle. So I could not call this by the vertex B, because you don't know if I mean this angle, or this angle. There are 3 choices. So you can name them only by the vertex, this, when there's only one angle and one vertex like that. Then you had to go through and estimate. We talked about how important it is to estimate the size of angles because that helps you look back on step 4 and check that your number makes sense. Some of you had the supplement to this. So you had, if this is an entire 180 degrees, 180 degrees, some of you had marked this 10 instead of the 170. So always look and make sure if it's bigger than a 90-degree angle, you know it's obtuse, the number has to be bigger than 90. If it's acute, your number has to be less than 90. So always estimate the sizes to make sure you're right. Okay, then we talked about where did this 360 degrees come from anyway? Well, it's easy to see if you slice a pizza. You guys know that each one of these are 90 degrees. And if I connect all of these with the pizza crust, okay, I've got 4 angles. And 4 times 90 is 360 degrees. So you know that in the entire pizza, which is a circle, there are 360 degrees. So the Babylonians are given credit with coming up with this number. And what they noticed is that in the sky, there were certain stars that were in the sky each night, but they slightly moved and slightly moved and slightly moved. And over the course of an entire year, they noticed that after a year passed, the same stars were in the same position of the sky. And remember, a year is the time it takes our planet Earth to make a revolution around the sun. And so they thought, it makes kind of a circle, and 365 days are about a year. But 365 wasn't as pretty of a number as 360, because I can find a half of this, a third of this, a quarter of this, a fifth of this, a sixth of it, an eighth of it, a ninth of it, a tenth of it, a 12th of it, a 15th of it, a 18th of it, a 20th of it. This has many, many, many factors, which makes it convenient for cutting up pizzas. So they decided on 360. So this pizza has been cut into 8 pieces. Some of you right away knew just to take the 90 and divide it by 2. Some of you divided 360 degrees by 8 to get 45. You're both correct. And then in terms of classifying angles, most of you already have learned this. So to classify angles that are less than 180 degrees, if they're exactly right for our wall to hold up our ceiling, then it's 90 degrees. If it's cute and tiny, like a cute little puppy or a cute little kitten, so it's littler than 90, it's an acute angle. And if it's a big, obese angle, bigger than 90 but less than 180, it's an obtuse angle. And if you have a straight angle, that is exactly, well, I should be doing this with the line drawing, but this is like your protractor. A straight angle is 180 degrees. So I can put my vertex right there, and that's a straight angle. So these 3 angles are smaller than 180 and bigger than 0. Okay, we did some practice on the clearboards in class. You measured angles, you drew angles, then I gave you your tangram shapes and you cut them out. And then for homework you had to make as many of the tangram shapes as you can and sketch your solutions. And then we came back today and looked at, are any of those impossible, and discussed those. And then the second half of this lesson was, we continued on with this content. So you had to begin with any 3 points not on the same line and connect them. And remember, a point is a location. So you labeled each point P, Q, and R. And when you connected them, you found that they made a triangle. And so then we want to be able to communicate clearly and effectively. So how do you name a triangle? Well, a triangle, really, this triangle PQR is equal to the union of line segment PQ, line segment QR, and line segment PR, because if I put them together, the union of them, I get this triangle. But I can also call this triangle RQP, and I also can call it triangle QPR. The order doesn't matter because there are only 3 points, and when I connect them in any order, I get just that triangle. So it just doesn't matter. And then we began with 4 different points on a flat surface, and you had to connect them in any order you want, but you had to finish where you began. So wherever you started, you had to finish in the same spot. And the figure that you got was the union of 4 segments, and we talked about what are the possibilities. So you guys did this in class, and these were some of the shapes you got. If some of your points are on the same line, that's called collinear points. Okay, this word collinear. Co means together in a line. There's the word line, and the AR is just the ending that makes it an adjective, so it's describing the set of points on the same line. These 3 blue points are all on the same line, so if I put my 4th outside of that line, so it's non-collinear with those 3, and I connect them, I get a triangle. And if I put my 4 points on my paper and I go in this order, down, up, down, over, and I end where I began. I get this bow tie shape. And if I go around them, I get a quadrilateral. Some of you also made a concave quadrilateral. So your 4 points were here, 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 and here. Pretend those lines are straight. Sorry about that. And then what makes this concave is this diagonal is outside of the quadrilateral, whereas these diagonals are inside. So that's just called a concave quadrilateral. So that was great. And then I had you connect any 5 points in some order and anywhere you began and try to make these shapes, and this is how you did it, and that was great. So some of them were collinear and some of them were not, depending on the shape you were trying to make. And then we talked about what makes a polygon, and looking at what is not a polygon is sometimes helpful to see what a polygon is. So this is not a polygon because it's not closed, and this is not a polygon because this line right here, let me go to the line symbol, let me change the color. Okay, this blue line right here intersects 3 other lines. It intersects this line right there. It intersects this line segment right here, and it intersects this line right here. So because the blue line intersects more than 2 lines and not at the endpoints, it's not a polygon rather. So let's look at the definition of a polygon. That might be helpful. So it's the union of segments in which each segment intersects exactly 2 others, and one has to be at each of the endpoints. So let's go back. So this blue segment intersects 3 lines, and they must connect at the endpoints, and it's not at the endpoint here. Right here, it's on the inside. Okay, they're intersecting not at an endpoint. So that's what's wrong with that. And then we classify polygons based on the number of sides. So the word tri means 3. So a polygon that has 3 sides is a triangle. Quad means 4 and lateral means sides. So 4 sides literally is quadrilateral. And then the rest of these follow a pattern. They all have the ending gon, and gon means angle. So this means 5 angles, 6 angles, 7 angles, 8 angles, 9 angles, 10 angles, and n angles. And n can be whatever you want. You can put the number 22 in here and it's a 22gon. So that means it's a 22-sided polygon. How do you name polygons? Well, you can begin at any vertex you want, and you can go clockwise or counterclockwise, but you must give them an order. So these are all starting at different vertices and going clockwise. So A, B, C, D, B, C, D, A, C, D, A, B, and D, A, B, C. And the green ones are going counterclockwise. So I'm going to go the other way. So A, D, C, B, DCBA, CBAD, and BADC. So I can actually name this quadrilateral with 8 different sets of letters. Then we did some activities again with heads together, heads apart with the clear boards, practicing lots of these kind of problems. And then you have a little bit of homework to do. And make sure you go to our class blog and read your project choices. You're either choosing sports team or architecture. And after today's lesson, you're ready to begin architecture. Sports team, you're not quite ready yet. You have to learn about how to graphically organize hierarchies first. And that's it.